Hey guys, today we are talking about applications of right triangles. So go ahead and label your notes 2.3 right triangle applications. Okay, so for the notes today, I picked out samples for problems that you'll kind of see like your assignment tomorrow in class. So you might not see a problem exactly like the one that I have on the screen right now, but you're going to use this type of logic in order to find the side lengths. So what I want y'all to do, you don't need to write out this whole paragraph. If you want to press pause so you can go ahead and write out the whole paragraph, that's fine. And if you don't want to write out the whole paragraph, just make sure you have this picture drawn. Okay? So a person on the edge of the canal observes a lamppost on the other side of with an angle of elevation. Okay, so we talked about that today, of 12 degrees to the top of the lamppost. And the angle of depression is 7 degrees. Okay? To the bottom of the lamppost from eye level. The person's eye level is 152 centimeters high. So let's go ahead and mark this length as well. So 152 centimeters. Okay? Find the width of the canal. Okay? And find the height of the lamppost. Well, the first thing we need to do, we have to first find the width of the canal, which is actually the same distance from the person's eye level to the post. I mean, it's not 100%, but that's what we're going to use. Okay? So this is my right triangle here. Okay, so if I was to redraw this properly to where everyone can see it, okay, we know 152 goes there. We know theta is 7 degrees. And we want to find x. Okay? So our two knowns are 7 degrees and 52 centimeters, and we're trying to find our adjacent. So we have to use tangent because it's opposite and adjacent. So we have tangent of 7 degrees equals 152 over x. Now I showed a bunch of y'all this today, but whenever you're dividing by a variable, you can just switch what it's equal to. So you get x equals 152 divided by tangent of 7. Okay? Now, when you have, get my calculator out, so you're going to use, make sure your mode is in degrees, and do 152 divided by tangent of 7. You get x is equal to 1,237.94. And we're going to assume it's in centimeters. Okay, so now we got this is 1,237.94. Okay? So we found A. The width of the canal is, what we just wrote down, 1,237.94 centimeters. Okay? Now they want us to find the height of the lamppost. So we have part of it. We need to find eye level to the distance up. Okay, so which brings us into our next triangle we have to use. So it's my x now. I know the width of the canal, which is that, and then I know my theta, which is 12 degrees. Okay, so again, theta is 12. That's my known. My adjacent's also my second known. My unknown is my opposite. So I'm going to use tangent of 12 equals x over 1237.94. Okay? We don't have to switch anything because x is now on the top, which means we're just going to multiply on both sides. 37.94. So those cancel. So x equals 37. 263 centimeters and 0.32. So 263.15. So you just have to add those two together, and then our distance, or the height of the lamppost, is 415 centimeters and 0.13. Okay, we're going to do one more problem. We're not going to do 4 because 4 is pretty much exactly like the one we just did. But we are going to use problem 3. So I'll go ahead and pause it if you want to draw this, or if you want to write this problem out. If not, let's first read it through. A swimming pool is 3 feet deep in the shallow end. The bottom of the pool has a steady drop of 12 degrees towards the deep end. If the pool is 50 meters long, how deep is the deep end? Ooh. All right, so we got 3 feet here. We know that so imagine this is the top of the pool. And I actually want to do something. Let me erase something real quick. I think this will help. Okay, so then we know that it goes like that. So I didn't draw it 100% correctly, but you get the idea. Let me erase this little bit quickly. Okay, so you want to draw a horizontal line. Okay, they're telling us that it's 50 meters long. And they're also telling us that the degrees, so basically this would be the angle of depression, would be 12. Okay? They want to know how deep is the deep end. Okay? So we need to find that length I just drew and then add it to 3. So it's this plus 3 gives us our entire deep end. Okay. So if it helps you, redraw the triangle to where it's set up properly. It helps me. I'm very much a visual learner, and I feel like most of y'all are too. So we got 12 here, and then we've got 3 there. So it's not exactly the exact same orientation. I flipped it and reflected it, but I feel like it will help for those of y'all that are visual people as well. Okay? So they want us to find, what do they want us to find? You know what? I just drew it wrong. See, teachers make mistakes too. Okay, so we're trying to find x. That's the x we're trying to find. So let me change this to x so it stays the same. Okay, the 3 doesn't really matter until the end because we have to add the depth of x plus 3. So I'm sorry about that. Okay, so 12 is our theta. Okay, we're looking for our opposite side and we have our adjacent. So that means we are going to use tangent of 12 equals x over 50. And the more practice you guys do with these, the easier this is going to become. Okay, so we're going to get rid of the 50, you multiply on both sides, and you get x is equal to 50 tangent of 12. Okay, if I go too fast, guys, press pause so you can catch up. And then just pick up where we go. So a couple people said I talk too fast. So just pause it and get caught up, and then you should be okay. All right, once you get x, you get 10.63. Okay, so that's the depth of x, but you got to add 3 to it, so the total depth of the deep end is 13.63 feet, which is actually pretty deep for a swimming pool. Usually swimming pools are only 10 feet. Okay, so I gave you 2 examples of problems that you will see on your assignment tomorrow. You can't get stuck on those. You just have to draw pictures and then find the right triangles. And it's really not that bad. make sure you take notes on this and you bring your notes tomorrow. And you should be good. Thanks for watching.